Here, we will go into the Fluent solver and specify the governing equations that we needed to solve. If I go to the Workbench window, I will right-click on Setup and select Edit. I can also double-click on it. And the Fluent launcher, I will select Double Precision, which is going to use 64 bits for each floating point number. That'll reduce round-off errors. The trade-off being it'll use more memory. Once the Fluent interface comes up, we can go in over here and check that the mesh came in okay, and it's not complaining over here, so that looks fine. And we can go into display and we can see what surfaces came in. So we see all our labeled boundaries came in, and the domain also came in. So this looks good. And you can deselect everything and select each one in turn and say display, double check which corresponds to which surface. And I can zoom in over here so you can see your zoom controls, pan controls, and so on over here. So if I zoom in here, I can see it better, and then if I look at the wall unheated, it's that, and so on. I'll just select everything, say display, and close. Now, when, if I go back to the project page, when we set properties to 2D for the geometry over here, okay, analysis type to 2D, and we selected the analysis, fluid flow as the analysis system, it already used those clues to turn on conservation of mass and momentum. So if I go to my slide here, conservation of mass and momentum are already turned on. Energy is not turned on yet, but it's turned on the 2D Cartesian version of these equations. So the conservation of mass is, or the continuity equation is in this form. So we need to switch to the cylindrical coordinate system. Let's do that. And all you need to do is click on axisymmetric. And now it is using the cylindrical coordinate system. So you have to interpret this coordinate, pardon my chicken scratch, as z, our axial coordinate, and that coordinate as the radial coordinate. And let's turn on the energy equation, which is not turned on by default. So I will expand models, double click on energy, and turn on the energy equation. So if I go here, so now it has our 4 equations that we wanted to solve, but we need to give it the right values of the material properties that appear in the governing equations. So that would be rho, mu, Cp, and K. And on this slide, I have put in the values from the problem specification that we need to enter. So let's give it the right values of these constants in the governing equations. I'll go back to Fluent. I'll expand materials and expand fluid and double click on air, and density is 1.2. So it's the numbers that you're given are rounded off. They're essentially properties of air. And you can see you have various other ways of specifying density, and if it's not a constant, it'll couple the energy equation to the mass and momentum equation, but we'll keep it constant. Cp is 1000 in SI units, thermal conductivity is 0.2, and the coefficient of viscosity is 1.8. Okay, and those should be the values shown over here. And I'll say change create. And we need to make sure that that material is assigned, and that you do it under cell zone conditions. So I will expand cell zone, double click on flow domain, and if I say, so the material is air, and if I say edit, I can see the values that are assigned. This becomes an issue if you have multiple materials. I've seen students trip up in that they think they just need to specify it over here. So it's a two-step process. You need to specify material properties, and you need to make sure you assign it. So that's all there is to specifying the governing equations. So I can save my project.